Here we have question 2. We're going to start off by focusing on the left-hand side. So we have cos 2x times tan x over sine squared x. Let's write that down. Now we notice that we've got this double angle of cos, and there are 3 different expansions. However, seeing that the final answer that we need has cos and sine in it, I'm going to use the expansion that has both cos and sine. So when it comes to these questions where you're proving left-hand side equals right-hand side, choose your expansion for cos 2x based on the answer that you need. If you notice that the answer has both sine and cos in it, then go with the expansion that has both sine and cos. So here we have it, cos squared x minus sine squared x. Next to that, we've got tan x. And we know tan can be rewritten as sine over cos. So there we have it. And I've also written the denominator. Now, what's going to happen in this step is that your bracket can multiply with sine x over cos x. So that sine x over cos x is going to multiply into the bracket with cos squared x as well as with negative sine squared x. Now, first multiplying cos squared x with sine x over cos x, what's going to happen is one of the cos is going to cancel out with the cos from the bottom. So that is actually just going to give us sine x cos x. We're now going to multiply negative sine squared x with sine over cos. That gives us negative sine cubed x over cos x. And let's just place our denominator as is. And that is sine squared x. What I notice now in my numerator is that I am subtracting 2 fractions with different denominators. Remember this, sine x cos x is a fraction because it's actually over 1. And I've showed you the rule in the previous question. When you are subtracting fractions with different denominators, your aim is to get the same denominator, or an LCD as you've learned it in primary school. Now to do that, we multiply both denominators together. So 1 times cos x is cos x. We then cross multiply. So we're going to take this cos x and multiply with sine x cos x. And that gives us sine x cos squared x. Since we have a minus in between, we're going to keep that minus and we cross multiply the other way. We have 1 times sine cubed x, which is sine cubed x. Now, personally, I don't like working with fractions within fractions because it easily confuses learners. So what I suggest is if you find yourself in this situation where you've got fractions within a fraction, change your main fraction line into a division. So we're actually dividing by sine squared x. Now, this is a lot easier to interpret. To simplify further, what we now notice is that in our numerator of the first fraction, both of them contain sine x. So we can actually pull out sine x as a common factor. So here we have it. Taking out sine x from the first term, we're left with the cos squared x. And from the second term, we're left with minus sine squared x. Now here, in the previous step, we were dividing by sine squared x. You know that when you are dividing 2 fractions, you change the division into a multiplication, and your second fraction gets inverted. Now at this point, you are allowed to cross-cancel. If you notice any of your numerators and denominators are the same, they can cancel out. So in the first fraction, we've got sine x, which is going to cancel out with one of the sine x from the bottom. Now we can multiply our fractions together. So multiplying our numerators, we have this bracket times 1, so it stays as is. In the denominator, we had cos x times sine x. When I multiplied them, I just put the sine x first, but it's not necessary to do that. Now at this point, it's important for these type of questions that you always go back and check what the answer that you need is. So if we just scroll back up, we notice that we need cos x over sine x and we need minus tan x. So these are 2 separate terms. However, we have one term here. But we can get this as 2 separate terms. You know that with fractions, If you have more than one term in your numerator, you can split the fraction up, where you share the denominator with each term in the numerator. So doing so, this is what we have: cos squared x over the denominator minus sine squared x over the denominator. And when we've separated it like this, we notice something important. One of the cos x from the numerator can cancel out with the cos x in the denominator, and in the second term, one of the sine x from the numerator can cancel out with the sine x from the denominator. Let's write down what we're left with. We are now left with cos x over sine x, which, hey, actually matches the answer that we need. There's it, cos x over sine x. And in the second term, we have negative sine x over cos x. And that is now equal to the right-hand side. So that gets you to the answer that you needed. Now, let's see where those 5 marks were allocated. The first mark was allocated to expanding cos 2x, so the expansion that you used. 1 mark for expanding tan x. Thereafter, 1 mark for where you simplified your fraction in your numerators. 1 mark for where you further simplified and you got them as 2 separate fractions. And the final mark was for having this step just before you changed it to the answer. So where you had cos x over sine x minus sine x over cos x. So that is your 5 marks. Please remember to like, subscribe, and turn on your notifications for more content.